Welcome to part 3 of the Module 9 exam review. We're going to pick it up at number 14. And my goal is to do 14, 15, 16, 17, and 18. That would probably take us at least 10 minutes. 19 if we have time, but we'll check into that. So, first one is Andy has 31 coins made up of quarters and half dollars. The total value is $11.25. How many quarters does he have? So since we're trying to find how many quarters and how many half dollars, we're just going to let Q equal the number of quarters and H equal the number of half dollars. And we'll do it like that. So if there's 31 total coins, we can say Q plus H equals 31. Okay. And then similarly, if their value is $11.25, we're going to equate money. So quarters are 25 cents. So 25Q plus half dollars are 50 cents. 50H. And notice, I'm doing this in cents, so when this equals the total amount of money we have, that $11.25, we want to do that in cents as well, 11.25. So 1,125 cents, because our quarters in cents and our half dollars in cents. So we want to know how many quarters he has, so because we just want to know how many quarters he has, I'm going to eliminate the H's here by multiplying by negative 50. Okay, so when I do that, you're going to get negative 50Q minus 50H equals negative, calculator out, so 31 times 50, negative 50 is, negative 1550. Okay, so adding these up, we're going to get negative 25Q. Our H's cancel. And then adding this over here, we're going to get negative 425. Divide both sides by negative 25. And 425 divided by 25 is 17. So there are 17 quarters. Now, it just asks for the quarters. If we want to know how many half dollars, we could substitute this back in this original equation, solve that for H, and get the half dollars. But because it only asks for quarters here, that's all we're going to do right here. Okay, so the next one says Ron and Kathy are selling tickets at their class play. Ron handles student tickets that sell for $2. Kathy's handling adult tickets that sell for $5.50. If their total income is $25, if their total income for $25 is $70. Excuse me. If their total income for 25 tickets was $71, how many did Ron sell? So if we let R equal the number of student and K equal number of adult, then we can go ahead and do this. So if Ron and Kathy sold a total of 25 tickets, we can say R plus K, that is the number of students plus the number of adult tickets, is 25. Now we're going to equate it via money as we've done before. Now, if the student tickets are $2, 2R. Now, the adult tickets are $5.50, so we'll say 5.5K, equals the total amount of money they brought in, $71. So here, I'm going to go ahead and just eliminate the R's, multiply by negative 2. Negative 2R minus 2K equals negative 50. Add these up. These go away. This is 3.5K equals, here we're going to have 21. So we have 21 there. Divide by 3.5. And 6. So K equals 6, which means that we've sold 6 adult tickets. Now, if there's 25 total tickets sold, we can plug this back in for K to solve for R, or we can just take 6 away from 25, which is what we'd be doing. So there's 19 student. So that is the way that one works. Now, those are the story problems with the little 2 variables. We're moving into the equation with the 3 variables, and we're just going to just go right through these. So we'll see what we can do. So the first one, we have x plus y plus z equals negative 3. And then we have x minus y plus 3z equals negative 7. And already, like, I'm thinking to myself, well, if I add those two together, the y's would go away. So maybe y's are a good one to eliminate in this. The third equation, 2x plus y plus z equals 2. And just a quick analysis, like, yeah, the y's are going to be the easiest thing to get rid of. So what I'm going to do is add these first two equations together. And because I don't need to multiply by anything, I'm just going to do this kind of visually. Now, on the exam, I would recommend you taking those, putting them somewhere else and adding them. But if you feel comfortable with this, feel free. So if I add the x's, x plus x is 2x. The y's cancel. Z plus 3z is plus 4z. And then negative 3 and negative 7 is negative 10. Okay, so I just visually add those two things together. Now, I'm going to do the same thing with the second two rather than rewrite these down. Or, you know, you can just put the little line right here, and we're just adding these second two. So that's going to give us 3x. The y's go away. Plus 4z equals negative 5. So put this over with our other equation that just has x's and z's. Okay, so here, I mean, it looks like the z's are really kind of set up to get rid of each other. So elimination again with the z's. When I multiply in by negative 1 here, I get negative 2x minus 4z equals a positive 10. Add these two guys together now. So we get x equals 5. So because these are ordered triples, we know our x equals 5. We want to find our y and our z. To find our z, we can plug this back into one of these equations. I'm just going to plug it in over here because it's kind of clean and out of the way. So we have 3 times 5 plus 4z equals negative 5. So 15 plus 4z equals negative 5. Subtract our 15s. So take this over here. So those cancel. So we have 4z equals negative 20 divided by 4, and z equals negative 5. So we have our we have our x and our z. To solve for y, let's use this first equation. So we'll go ahead and plug it in over here. So we can say 5 plus y minus 5 equals negative 3. Negative 5 and 5 cancel, so y equals negative 3. And that's the way we do that one. So moving on to the next one. Once again, we have 3 variables and we have 3 equations. So when I write these down, I'm kind of thinking to myself, what might be the easiest thing to get rid of? So if I have 5x plus 2y plus z equals negative 11. Z's already look good because we only have one z and it's easy to manipulate that. Now, the second thing we have is 3x minus 2... Whoops, excuse me. We have... Let me get that again. We have 2x minus 3y. So 2x minus 3y minus z equals 17. Now, yeah, the z's are looking good to get rid of, so I'm probably going to do that. Now, the last one we have is 7x plus y plus 2z equals negative 4. Okay, so let's just go ahead and do this. Now, I'm going to eliminate the z's, so if I add the first two together, I'm going to do that visually again, really without doing a whole lot of writing anywhere else. Feel free to write these down somewhere else if you're not comfortable doing this. Now, 5 and 2 is 7, so we have 7x. The y's, we're going to have a negative y. The z's cancel. And then negative 11 plus 17 is 6. Now, I'm going to use these second two to get rid of the z's again, but I am going to rewrite this middle equation right here because we have two z's here, we have a negative 1z. I'm going to multiply this whole row by 2. So doing that, distribute all the way in. Our 2 times our 2x is 4x. Our 2 times our negative 3y is negative 6y. Our 2 times our negative z is negative 2z. And then 2 times 17 is 34. So let's add these up. So this is going to give us 11x minus 5y. Z's cancel. And this is going to equal 30. So we put this over here. So we have 11x minus 5y equals 30. So just looking at these two equations over here, it looks to me that the y's want to be eliminated. I think that's going to be the easiest thing to do. So I'm going to multiply this top equation by negative 5. So bringing in here, this is going to give us negative 35x plus 5y equals negative 30. So 11x and negative 35x is going to be negative 24x. The y's cancel. 30 minus 30 is 0, so we divide by negative 24. Cancellation here, so we get x equals 0. So in our ordered triple, our x coordinate is 0. We want to find our y and our z's. So to find our y, we can plug this back in. I'll just go ahead and plug it in over here. So we have 11 times 0 equals, 11 times 0 minus 5y equals 30. Uh-oh, there the dogs go. Right! Then here we want to divide by negative 5. Sorry about that. These cancel out, so we get y equals negative 6. So 0 and negative 6. To get our z, we're going to go ahead and use one of the original ones. I'm just going to use this top one because it's got a 1z. Looks like it's pretty good to go. So I'm going to go ahead and plug that in right here. So I have 5 times 0 plus 2 times negative 6 plus z equals negative 11. Okay, so now solving this for z. 5 times 0 is 0, so that goes away. 2 times negative 11 is negative 12, plus z equals negative 11. Add 12 to both sides, we get z equals 1. Okay, so our solution, 0, negative 6, 1. And that is that one. So, let's do one more, and then that's probably good for this video. So, number 18 here, just writing it down, we have a 2x plus 2y, 2x plus 2y, plus z equals negative 2. So z is looking good again. 5x minus 5y minus z equals 19. Z is definitely looking good. And then the last one, just like we had before, we have a 2x plus y plus 2z equals negative 5. So we can essentially use the same technique as we did before because the z's are looking good to get rid of. So I'll add these first two together. 7x minus 3y equals 17. So just adding those first two equations together, we can get rid of the z's. We get our 7x, our negative 3y, and our 17. Now for the second two, we're once again going to have to multiply the second row by 2. So doing that, we're going to have a 10x minus 10y minus 2z equals 38. So adding these up, we get a 12x minus 9y. The z's go away. And then this equals 33. So write this over here. So we have 12x minus 9y equals 33. So looking at those two equations right there, it seems to me that the y's want to leave because 9 is a multiple of 3. So if I multiply this by negative 3, we get negative 21x plus 9y equals, and I believe this is negative 51. So let's run with that assumption. So 12 minus 21 is going to give us a negative 9x. The y's go away. 33 minus 51 is going to give us 20. The handy calculator again today. So it's going to give us negative 18. Divide by negative 9. Those cancel and we get x equals 2. So, we got our x coordinates 2. Now to find our y, let's go ahead and plug it back in here. It doesn't really matter. So we have 12 times 2 minus 9y equals 33. So 24 minus 9y equals 33. Subtract 24. So negative 9y. So these cancel. Our negative 9y carries over. 33 minus 24 is 9. Divide by negative 9. And we get y equals negative 1. So our y equals negative 1. Now, I'm going to go ahead and plug this back in the original equation, the top one, and that seems to be the easiest one to probably use. So we have 2 times 2 plus 2 times negative 1 plus z equals negative 2. So here, 4 minus 2 plus z equals 2. 2 plus z equals 2 minus 2. Z equals 0. So our solution 2, negative 1, 0. So hopefully that made sense. We'll come back and do 19 and probably 19, 20, 21, 22, and 23. If we can get those done, then we're done with the systems one. All right, see ya.